Hey, what's up, guys? My name is Cherno, and welcome to a pretty much casual video that's just gonna sort of slightly analyze Time, which is the game that I made for Ludum because the results came out like today or yesterday or whatever. So I actually did pretty well. Okay, not gonna lie, I didn't expect this. So these are the results. I think we came like number 400 or something overall out of like 2,000 games, but in audio, I came 10th. So here I am right here. And for mood, I got 48, I think, if we just take a look here. So these are the ratings. So not bad. I mean, I'm pretty happy with that, to be honest, because this is an unfinished game, right? This is a prototype game. So we ranked pretty well. Audio, I honestly have no idea how I got 10 for that. I didn't have any sound effects whatsoever. I just had a music, which I wrote in about, I don't know, an hour. So wasn't great, but number 59 in theme is pretty high as well. So that's probably the best result I've gotten like ever in Ludum. This is my third Ludum. The first one I did was Genesis. In fact, I think if you click on my profile, which is how do I even do that? I think if you view my journal, which is somewhere, yeah, there it is, or view all entries by Cherno. So Genesis Genesis got like number 116 in audio, 280 overall. It got better overall, but worse in other categories. Squared, I think, was pretty bad. Squared, like I didn't even rate any games. I don't know how I got barely any coolness. But yeah, so time is good though. And it's a very, very cool concept, which I've been meaning to develop for a while now, but I just been so distracted with uni and stuff. But yeah, so I thought I'd just share my results with you guys. And I thought I might as well just analyze some of the code with you. Just some of the code with you. Because otherwise it would take too long. So if you're unfamiliar with what Time is, it's basically a game in which it's more or less a prototype game that because the idea I had was very cool. But the reason that I didn't have time to develop it was because, of course, for Ludum I write my games from scratch, and just writing the engine takes so long. It takes like 80% of the time. So the idea was when you hit a shifter, it transports you 10 seconds back in time. So if I hit this guy here, there you go 10 seconds back in time. So that was the entire concept, really. So there's text on the floor, which is from a technical standpoint. There's obviously a clock here. There's well, I guess the big technical thing in this is probably going back 10 seconds in time. But the other thing people were asking me about was this thing. So when you hit this, there's like a little cutscene that plays, and a lot of people were like, "How are you doing that?" That's really cool because this isn't a video. This is actually the way that I did this was very, very simple. Basically, it was just I think like 300 frames, 300 PNG images, and they were just animated essentially as if it was an animated sprite. And then this level, which is just hilarious because at this point I'm like, yeah, screw it, this is just going to be a prototype, so I made this ridiculous level. So the code, okay? One thing that I did here probably, which was different from other games, well, we haven't covered states yet in the game programming series, so that's one thing that obviously I implemented because there's a menu in here, obviously. Whoops, keeps opening on my other screen. There's a menu in here, obviously, and that works and stuff. But states we haven't covered. What else haven't we done in menus? Otherwise, it's pretty similar. It's pretty similar to the Rain game that we're making in game programming. What else is new? Oh yeah, there's a separate thread here running for loading, because loading was very challenging. What it actually happens, and I can't really show you guys this because it's on another screen, but you can see that while it's loading, it actually displays a screen that says loading. And that can be updated, of course, and that's all thanks to the fact that we can use threads, because threads essentially just enable us to do multiple things concurrently, right? They let us run multiple lines of code essentially at the same time, and so that's why we can be loading as well as actually updating our display. So if we load on one thread and update our display on the other thread, we can actually animate our progress like that. Now, while I didn't end up making an animated progress bar because that's just not the time, not the stuff you have time for when you have 48 hours to write a game, it pretty much functions the same way with loading screens. So what happens is some of the cool stuff I wanted to cover with you guys is the sprite array here, which is very similar to the animated sprite that we did here. You can see that one of the sprite arrays. Now, sprite array is, I think, it's essentially just an array of sprites, right? I think we did pretty much the same thing in the animated sprite class in game programming. I think that's like episode 87, 88-ish, maybe even 89. Not 100% sure there, but you can see that the width and height, I think, is 340 by 212 of each sprite, and there are 169 total sprites. So you can see that it makes a new array with 169 sprites. That's primarily why the loading took so long. Not the best way of doing it, I know, but hey, I didn't have much time to come up with a better method here. So that's how this handles. So this is basically identical to the animated sprite class. What else do we have here? Text. Okay, text is interesting. So text is text gets stored as a sprite, and all that happens, and by text I mean not like this text, or this text, but the actual text on the level here. So this stuff. This stuff basically just gets it's an image, right? And then what happens is that image actually just gets placed onto the level as a sprite, essentially. So it's pretty basic as well. And of course it does have that offset. So in render sprite, obviously there is that offset that ensures that it stays there at all times. So that's a pretty basic thing. Of course, that is a PNG. It's not a PNG. It is a PNG image, but of course it just ignores the if the color equals. If the color doesn't equal pink, then render. That's how we get the alpha transparency here. Okay, what else is there? So levels are pretty basic. Oh yes, let's cover this. Okay, so there's this thing called a timeline. Yeah, this is interesting. So this is probably the most requested topic here. So there is this thing called a timeline. And this timeline is responsible for actually, I guess, storing the state of the game as the player plays on. And while I didn't have time to absolutely eliminate all bugs from this and develop it correctly, the idea was definitely there. And the idea of this is basically having an array list which contains array lists of vector. And vector is a class that originally just had X and Y, but I obviously added stuff to it, so it's not really truly a vector anymore, of course. But what it would do was store the location and the type. And what would happen is when you got transported 10 seconds back in time, all that would happen is because it actually caches everyone is essentially every entity in the level, because it caches that stuff once per second. All you would have to do is literally, if you knew what index you were up to right now, you just have to go back 10 indexes. And what you would actually get, so index minus 10 essentially, and what you would get is a state of the world 10 seconds ago. Very cool way of doing it, very lightweight, because all we're storing is the type. We're not even storing the object, we're just storing the type and the X and Y. That's 2 integers and an enumeration, okay? Very, very lightweight class. Couple of bytes, honestly, a bit more than a couple of bytes, but very, very low amount of data here, which uses almost no memory as well, as I guess contrasted to storing the entire class, which wouldn't be anywhere near as efficient. And what happens here is restore time. Okay, so the restore time method and the timeline method. So what happens is you can see that this is an array list of vectors here, and it's a local variable, and for every entity, essentially what happens is it gets we create it and we add it to the array. So you guys should probably see here what's happening roughly. So again, we create a new entity that contains the appropriate entity in the entities array, which is of course our array of every single entity that's currently in the level, and we create a vector out of that. So a vector object out of that, which don't take it as a mathematical vector. Clearly it's not, but it's just called vector because I didn't bother changing the name. So vector dot type. So I guess we set the type here equal to what we want it to be, and then we add the vector essentially into the thing with the appropriate type as a new vector object. So it's it's pretty basic here. And of course, then we add this array. So it creates a vector object out of every entity in the level at that particular second and adds it. And all it stores about them is the type of entity they are and their position. That's it. Of course, I guess you'd probably say that it's not in the strictest sense, because we don't store where they go to next. So, in other words, what happens is if you go back in time, well, I guess that's kind of realistic, right? Because we're not going back in time in terms of actually to replay something, right? We're just going back in time to, and then of course we can change the future, if that makes sense. So we're not trying to replay our actions as if we were, I don't know, going back a scene on a DVD. Where we're just actually literally going back in time, and that's why, of course, everything is different the second time around. So we don't need to store that. So all we need to do is store entities' locations on the level, essentially, at that point in time. And then on restore time, what happens is the player class, the player has, when it collides with the shifter here, level.restore time fires, and travel time is actually set to -10 here. So what happens is it restores time. The parameter here is time, which is essentially the time. We go plus equals time because, of course, this is a negative value because we want to, restore time. I guess adds time, but that doesn't make any sense. But the point is that it adds -10 here. And let's see here. I haven't read this code in since Ludum Dare, by the way, so I'm just refreshing myself here as well. That's why I said it would be fairly casual. So if it's less than start time, of course, we set to equal to -1, which means that the player essentially loses, because if you go back too far, then, well, you don't exist yet in the level. That's why you lose the game, which is what happens here. Okay. So essentially what happens is so start time is actually set to 7,500. And the reason is if we set it to 0 here and we launch our game, obviously the time's gonna be 0 here, okay? And that just kind of doesn't look very cool. I just thought it'd be nicer if it was not exactly midnight. So I set it to 410. I don't know. I just added 7,500 seconds here, and there's a nice little algorithm, I guess. Not really an algorithm, but it basically just sorts out this time into seconds, minutes, and hours. Okay, and the other thing is, and then all it does here is essentially restore the restore all the entities into their locations. So I think that's pretty much it. Nothing here is really too groundbreaking, except for that. The way I handle levels is the same way that you would have seen in the game programming series. Shifters are. This AI isn't. It's not really AI. It's in fact there is a small bug in the game which I know about but never fixed. This really should be XA and YA. And essentially what just happens is every now and then the shifter will change which way they're moving. So very basic AI, but that's what we'll cover soon in game programming. And of course we will go into some actual AI. The thing is though, I didn't want any other AI. I just wanted, it's not. The reason I didn't make proper AI for this was not because I didn't have time or anything. It's just because so you can see they look a lot better, and then that's some pretty cool particles here as well. But so as you can see, if we touch them, we go back in time. The reason I didn't make proper AI here is because I didn't want I didn't really want these shifters to be following the player or anything or chasing him. I thought that if they would just roam randomly, that would be a lot, I guess spookier, because you have no idea when they're going to change direction. They've got a random chance to change direction into a random direction, every tick, essentially, every update. And that gives you a kind of mysterious factor, because you can't predict their movement at all. It's random. And because of that, I think that created a really nice feeling and mood, I guess, and aesthetic. But also, these guys are sort of here for ambience. That's why the shifters are really here. So I thought that was just a really cool addition. In fact, we've gone so far back in time, we've gone out of that spot. So yes, there is a way to win the game, of course. And if you guys haven't played it yet, there'll be a link in the description. But what I was going to do is essentially develop this in C++ and OpenGL. Maybe for my distinction project for university, because I have to do something for that. In like OpenGL or something, but we'll see. I don't know, I don't want to make too many promises, but I think this game is a pretty cool idea. So if I have time, which I definitely will over the summer holidays, which is, you know, for you guys in Europe, America, whatever, that's winter holidays, but for that, you know, I will have time for that. So, you know, we'll see, okay? But I hope you guys did enjoy the game. I had a blast making it. I learned a few things about Java, such as the way that it copies objects and the way that it handles pointers to objects, because of course in C++ and stuff you have to specify what you want to be a pointer, what you want to not be a pointer. In Java it just kind of does that automatically, so you have no idea. Like, you know, integers by default of course aren't pointers, but objects, I'm still undecided whether objects are pointers or not. I don't think they are, but like arrays are pointers. So if you pass an array through a parameter, then it ends up being a pointer. So I guess that is a pass by reference kind of thing there. But I did learn a heap, okay, and I had a lot of fun with you guys, because there was like 250 viewers like most of the time. So I had a really good time with you guys, and I did answer a lot of questions. So I hope you guys did enjoy the stream, but I'll definitely be doing next Ludum there, because that'll be during my break as well. And one other thing I'm doing though is because I think the problem with this game, or I guess the reason that I think I didn't place higher was probably because I just ran out of time, okay? And I spent like 20 hours developing this. I know every Ludum there I'm like, yes, I'm totally gonna stay awake for like 48 hours. I end up like going to bed, sleeping like 9 to 10 hours per night, as well as like doing other work. But the other thing is, there's just, because I write it from scratch, there's just not enough time. And I don't want to use like, because, okay, this is another thing, right? So most of the top games here, if we actually have a look, this is the top game that won, called Probe. I had a blast playing it. It is written like with Unity. Of course it is. All of these guys are using actual frameworks, actual libraries, actual like, well, I guess Unity's more of a SDK even. It's more of like a game engine kind of thing. People are using all this stuff, and because of that, they're focusing less on the graphics and more on the gameplay. And that's really the thing that wins, of course. I don't want to be spending this much time on graphics, which is why, like, honestly, for the past year, I've actually been developing a framework that fast tracks game development in a very, very simple way as well, that that you guys are all used to as well. So hopefully I'll be able to use that framework as well as release it to you guys by next Ludum Dare. So I think that'll be great. And the thing is, that will actually eliminate the need to just type all this code over and over again, and it'll really make the game development more focused on the gameplay, which is something that I think is very important. So yeah, anyway, that's gonna wrap up this video, guys. I'll probably see you on Thursday night with another episode of game programming, but until then, later, guys.